Well, Pete, January 2023, and I guess we should say Happy New Year to all
Happy New Year.
Listeners. We will start, as ever, with the inner solar system. So the planet Mercury starts the start of the month not far from the planet Venus, which is really quite bright, but it's quite faint now, magnitude 1.6 on the 1st of January, and dims thereafter, so it's going to be quite difficult to spot in the evening twilight. Inferior conjunction, so this is when Mercury is between us and the Sun. This occurs on the 7th of January, and after that, Mercury returns to the morning sky, and will be visible there. But it's going to be a bit tricky, I think.
It will. On the 19th of January, it'll be at mag plus 0.5, and there'll be a slender 9% lit waning crescent moon 16 degrees to the right of it, as seen from the UK. Greatest western elongation occurs on the 30th of January, when the planet will be 25 degrees from the Sun. It shines at mag 0 then, and it will rise an hour and a half before sunrise on that date, visible low above the southeast horizon. So that's probably your best time to try and spot it, actually, towards the end of the month. What about Venus then? Well, we've mentioned Venus. Venus is a brilliant magnitude minus 3.8 evening planet, and that's really exciting, as we began to mention last month, because Venus is now starting to move into a prominent position in the evening sky, isn't it?
Yes, it's getting quite good. So Venus is now coming towards us, and as a result of that, its apparent diameter, as seen from the Earth, will start to get larger, and the phase will start to decrease. So it's gibbous at the moment. In not too long, it'll be half moon dichotomy shape, and then it'll become a crescent. So it'll be interesting to follow these changes. We've seen some interesting phenomena on Venus. If you image it in infrared, we've seen this wave phenomena that's appeared.
Oh, yes.
That's come and gone. And when we get down to the crescent, although it'll be tough for UK observers, we should all be trying to image the night side and look out for the ashen light if it turns up. So there'll be plenty to see on Venus, and it's nice to have it back in our evening skies.
We get it actually will do what it normally does. It'll look really prominent through the winter and the spring, but then it will start to get quite difficult, won't it, as you go into May and June time. And inferior conjunction, I think, occurs in August, but it passes a reasonable distance from the Sun when it reaches inferior conjunction. So if you know what you're doing and you're really careful, you will be able to watch it as it goes through its thinnest part of the crescent. But unlike back in, when was that, 2020, when it got really close to the Sun and it showed as an atmospheric ring, it won't happen this time. You'll start to see the cusps extending, but it won't be close enough to the Sun to get any more exciting than that. But trying to image the night side is quite tricky.
It is, because you have to block out the brilliant crescent.
Yeah,
but
you do.
A number of amateurs are doing this routinely now at this point in the elongation when Venus is a thin crescent.
Yeah.
So it's worth having a try.
Well, we should also mention that Venus is close to Saturn on the 22nd of January, with the two worlds being just 26 arc minutes apart at sunset. So that's approximately the diameter of the full moon. Saturn will be harder to see, of course, because it'll be dimmer, it'll be mag plus 0.8. And on the following evening, the pair will appear separated by just under a degree, with a beautiful 5% lit waxing crescent moon 5 degrees to the southeast of the Venus-Saturn pair. By the end of the month, Venus sets 135 minutes after the Sun, which is quite impressive.
It is, more than 2 hours, so that's quite good. Mars, well, this was at opposition last month, so it's still very well placed in the sky.
I thought you were going to say it was at opposition last month, but now it's going to be rubbish again.
No, not at all. In fact, it's going to be good, and it's still good, and you could still use a small telescope to view the surface details.
It's a frustrating planet. I've always found Mars really frustrating, because you get the opposition when it's or a few months before and after opposition, when it's really well placed, but it rushes away from the Earth very quickly, doesn't it?
It does, and then it's gone for a while before it comes back. There's a number of things you'll be able to see on the disk, though. I think even a 4-inch telescope will show the most prominent markings, like the Canis Major. We've had the return of the northern polar hood in the bottom. If you've got a mirror inverting telescope, then the northern polar hood, this bright region, should be visible. And it would be interesting to follow. There'll be bright white clouds that collect over the volcanoes and come onto the disk. They can be very, very prominent. So plenty to see, really, on Mars still.
Because the northern polar hood throughout January should start to break up, shouldn't it?
Yes, that's right. So we should start to see that break up and disappear with the cap, the northern polar cap there. And one thing to watch out for is you do get this strong bluish haze over the northern polar hood, and it can be quite obvious even in an 8-inch telescope. So,
right,
and it's certainly easy to image. So, there's definitely plenty worth following on Mars. Just because it's past opposition doesn't mean we should stop following it.
No, and having said that, in December, when it reached opposition, it got to a maximum apparent size of 17.2 arc seconds. And at the beginning of January, it'll be 14 arc seconds across. The middle of January, it'll be about 12 arc seconds across. And at the end of January, it'll be about 10 arc seconds across. So although it is shrinking, it's still a reasonable size.
It is. And on the 12th of January, Mars reaches a stationary point. Before this, its motion was retrograde. The planet was moving west against the background stars. After the 12th, it will be prograde and be moving back east again.
Everything will be restored as it should be. Okay, well, Jupiter is still visible. It's best at the start of January, and thereafter it starts to lose altitude as darkness falls. There's a waxing crescent moon nearby on the evenings of the 25th and 26th of January, and MAG minus 2.1 Jupiter will form a striking sight next to the lunar crescent.
Yes, it'd be quite interesting to see that. Unfortunately, though, Jupiter's well past its best now, but it will be good again next year, where opposition will be slightly later next year than it was this year. Saturn is not very well placed. But Uranus is very well placed still for the evening. It's the highest planet in the sky. It reaches, I think it does get to naked eye threshold from a dark site still.
Yeah.
And on the 1st of January at 22:30, Uranus experiences a shallow occultation of the moon's southern edge. So that'll be quite interesting one to see, but a little bit tricky, I think.
It is a tricky one because it depends where you live. It's visible from northern UK. So if you live in the southern part of the UK, you'll see a near miss, which is still worthwhile looking for, I have to say. But yes, this is down to the fact that the moon is quite a close object to us, and your location tends to move its position against the background stars, an effect known as parallax. And so that's what causes us problems specifying absolute timings for events like occultations, etc. Lunar occultations especially will vary by a few minutes or even not happen at all.
Yes.
If it happens to be in extreme. But look in the magazine and you'll get more information about what's going on. Neptune, well, MAG 7.9 Neptune is 8 degrees west of MAG minus 2.1 Jupiter on the 1st of January, and the separation increases to 12 degrees by the month end as Jupiter is starting to lose altitude as the sky gets dark, so Neptune will undergo the same fate, of course. There is a 20% lit waxing crescent moon sitting between Jupiter and Neptune on the evening of the 25th of January, slightly south of the imaginary line between both planets, even though it will be quite difficult to imagine where Neptune is in that situation.
All right, well, we have some interesting specials this month. On the 4th of January, the quadrantic meteor shower peak is expected to occur at around 0400 in the morning. Unfortunately, the moon is going to spoil it. 92% lit waxing gibbous moon will interfere.
It will. And the quadrantic peak is quite short. It's only a few hours in width. But the good news here is that that's normally an indication that the other major showers throughout the year will be better placed in terms of the lunar phase. And that will certainly be the case for the main players throughout 2023, this being a very good year for meteor showers, just not the quadrantids.
Oh, well, we'll have to look forward to the other ones instead. On the 6th of January, the evening's full moon occurs near apogee. So this is the full moon occurring when the moon is at its furthest point in its orbit around the Earth. So it should seem to be, or should appear, slightly dimmer and smaller than the average full moon. And I think you're suggesting we call these micro moons because we haven't got
Nobody makes a fuss over this one, do they?
Well,
no, it is. It's not me suggesting it. That's what it is actually called.
Okay,
informally.
all right. So as if we haven't got enough daft suggestions already, we now have micro moons to look out for as well. On the 8th, the lunar libration has the moon's southern polar region tilted towards the Earth. This is actually quite a heavily cratered region of the lunar surface.
Moon, yeah.
So this is a good time to go out. Even a small telescope, or dare I say just binoculars, will show you the heavy cratering. And when that's in shadow, partially in shadow, it looks quite stunning.
It does indeed. On the 15th, we've got the Comet C 2022 E3 ZTF, and that's expected to reach magnitude plus 6.3. So right on the threshold of theoretical naked eye visibility. And the reason why we picked it out on the 15th is that on that night and into the following morning of the 16th, it's located just to the west of mag plus 4.6 Chi Hercules.
On the 18th, the waning crescent moon's western libration region is tilted towards us, and this will give us a nicer view of the Mare Orientale, this massive ringed basin on the western limb of the moon. I think was described once as the vast region beyond the Rook Mountains.
It looks like a bullseye. If you were above it, looking down on it, it looks like a bullseye. Mare Orientale is the dark patch right at the centre of the pattern, and then you've got the Mons Cordillera and Mons Rook with dark lakes in between them. So it's a fantastic structure which we can't see very well from Earth, unfortunately.
No, but the libration, well, we can try and catch the edge of it. On the 23rd, magnitude 5.6 Comet C 2022 E3 ZTF is currently near magnitude 3.3 Iota Draconis. So 5.6 is pretty good. And it starts to pass through some interesting objects, doesn't nearby some interesting objects.
So on the 24th, it's expected to be around, again, mag plus 5.6. Have to say, take those values with a pinch of salt because you don't know what is going to happen. There's no absolute. And the problem with a comet is that the magnitudes which are given are integrated magnitudes. So basically, if you were to take a comet which has a size in the sky and take all the light of that comet and squidge it down so it's a star-like point, that's the magnitude which is given. So if you have a comet which has a tangible size, that brightness is spread over an area, so its surface brightness is lower, and that makes it harder to see. But on the morning of the 24th of January, Comet C 2022 E3 ZTF is expected to be, again, at mag plus 5.6 and passes a couple of degrees east of the mag plus 9.9 galaxy M102 in Draco. And it's a nice thing to do to try and catch a deep sky object near a comet.
Yes, it's always interesting. On the 27th, the same comet is close to Cocab, known as Beta Ursae in the evening and the early morning. And then on the 29th, the comet is now expected to be around magnitude plus 4.9. So this really is naked eye visibility, if indeed it reaches that brightness. And it will be close to Polaris, which should make it very easy to locate.
Yeah, Cocab and what's the other one? Furcad, isn't it? The other one, which is those two stars which orbit Polaris in the sky. They are known as the guardians of the pole, which is rather nice. So they and Polaris make good markers to locate this comet. But as we say, mag plus 4.9, you think that's going to be easy naked eye, but I wouldn't expect it to be. I would think it's probably binocular or small telescope, if I'm being honest. But it might get brighter, but then again, it might get dimmer too. Should also point out that the ZTF in the name refers to the Zwicky Transient Facility, which is located at Mount Palomar in California, and that's a facility which is designed for looking for transient objects in the night sky, such as comets, which is why it's got its name associated with them.
Right, well, let's move on into the night sky. And similar to December, our night skies are dominated by the constellation of Orion. So we have the belt stars, and then the two other stars at the bottom right, we have Rigel, and top left we have Betelgeuse.
Yes.
Now, we mentioned last month Betelgeuse's variability in terms of its brightness and its colour. That has a knock-on effect of how far we think it is away from us.
Yes, it does.
So we think it's about 420 odd light years away, but there's some considerable plus or minus in that, depending on how bright and just how massive the star actually is.
It's quite ironic, actually, isn't it? Because there are a number of stars up there which have that uncertainty in their distance, and you've got the Gaia spacecraft, which is designed to do astrometric measurements, very accurate astrometric measurements of stars, but it struggles with bright stars, so we can't easily refine that distance.
No, I think it's going to have error bars on it for a while yet. The belt of Orion, well, this is those three stars that lie at the centre of the pattern, are very, very easily recognisable. They're roughly equal brightness.
Yes.
And it's quite amazing if you covered up all the stars and showed just the belt. I think most people would still be able to recognise it, because I think it's the belt that most people see first of all.
Yes, absolutely. And sometimes I've actually noticed, that's a very interesting point you raised there. I've noticed that when you have a situation, because there are other arrangements of stars which do look like enormous versions of the belt, and if you've got cloudy skies and a gap appears and you get three stars which look like they're in a line like that, it sort of engenders the feeling that you're looking at the belt of Orion. It's quite remarkable. These three stars stand out so well.
It is. Mintaka, the westernmost belt star, lies just 17 arc minutes below the celestial equator. This is the equivalent of the equator in the night sky, separating the northern hemisphere and the southern hemisphere.
Yes, and well, that's really useful, because when you watch the sky over the course of a winter night, Mintaka basically draws the celestial equator for you.
Isn't that helpful of it?
It's very helpful indeed. It's surprising how high it gets. Actually, you sort of it's good for giving you a degree of scale when you're looking outside at the night sky. I've always found that quite helpful, really. So if you follow the belt stars up and to the right, you come to the giant orange star Aldebaran in the constellation of Taurus the Bull, and that looks like it's part of the V-shaped cluster known as the Hyades, which is the nearest open cluster to Earth at a distance of 151 light years. Actually, Aldebaran isn't part of the cluster. It's about half the distance of that cluster. And interestingly, if you continue that line from the belt through the Aldebaran, and eventually you'll arrive at the Pleiades, or the Seven Sisters, and that's around 444 light years away, so it's much further away.
It is. And if you follow the Orion's belt down to the left, you eventually come to the brilliant star Sirius, about 8 light years away. This is quite a intense object. It looks incredibly powerful. That's just because it's fairly close to us and sparkles with all sorts of colours of light.
Yeah.
Now, Sirius is a binary star, and it has an older white dwarf companion, which is much, much fainter.
It's about mag 8.5, I think, the pup.
Which isn't very difficult. If that was on its own in the sky, you'd find that without too much difficulty.
Yeah.
But because it's it's next to such a brilliant object, the difference in magnitude, I find it makes it very, very difficult to see.
Well, this is the time to look for it, because it has they have a mutual orbit which is about 50 years long, and currently they're at their greatest separation. So this is the time to try and make that observation where you can split the pair. They are difficult because of the proximity of Sirius, and I've seen people take photographs of the region and say, I've got the pup star, and they haven't. And what you have to bear in mind is that the the distance of the two stars is measured in planetary imaging scales. So if you got a setup which, say, takes pictures of Jupiter, or you're observing Jupiter, that's the sort of image scale you need to see the pup away from Sirius. It's not wider than that, which is where the false positives come from.
Yes.
You have to get right in close.
You do, and you also have to watch out for reflections from Sirius, internal reflections. Yes. I do remember once I thought I'd seen it, and I wasn't entirely convinced. And I rotated the eyepiece, and Sirius B, what I thought was Sirius B, remained in the same, moved around actually with the eyepiece, which of course it wouldn't do if it was real. In fact, it was due to a slightly dirty mark on the lens, piece of dust.
Outrageous.
So you have to be very, very careful. There are all sorts of tricks that optics will play on you. So, but if you do zoom in, as Pete says, you should be able to see it with a larger telescope.
Another interesting point there, actually, which you need to bear in mind, is that if you're using a reflecting telescope, the diffraction spikes from Sirius, if you've got them orientated in the wrong direction. And let's face it, if you do it randomly, they're going to be orientated in the wrong direction. They're going to cover up the pup star.
Yes, I mean, it's the first rule in astronomy: everything must be as difficult as possible. So, of course, that's going to be the case.
Well, if you want to have a go at it, actually, there are various things you can try. One thing is to use a bit of aluminium foil and tape it across the focal plane of the eyepiece you intend to use, so it's a really sharp edge, and then work out the orientation of your view, and then go online, find a chart where Sirius is relative to the pup, or the pup relative to Sirius. In fact, we've covered that in the magazine a number of times as well. Then what you do is you align the edge of this aluminium foil so that it covers Sirius and leaves the bit of space where the pup star should be free to look. So it's an occulting bar. The other trick is to wait until, or go early, when the sky is still bright with twilight, and then look for it. You need to get that balance right, because it needs to be dark enough to be able to see the pup. But if you catch it before it's completely dark, then the contrast of Sirius is reduced, and that helps you to see what's going on. If you have an imaging setup, you set it up as you would for imaging Jupiter, that sort of image scale, and put an infrared pass filter in front of your camera. Now, the camera obviously has to be infrared sensitive to do that. A monochrome camera, or some of the modern colour cameras, are pretty good for that. And the pup does stand out pretty well.
Okay, well, apart from Sirius and the pup, there are other things in Canis Major. For example, we have the lovely open cluster M41, just 4 degrees below Sirius. That's worth a try. And there's also the Tau Canis Majoris cluster, a group of stars arranged in a fairly vague triangular fashion all around the star Tau Canis Major. In fact, this cluster looks fantastic through a telescope. It is actually one of those hidden jewels, I think. I've only seen it a couple of times, and I stumbled onto it by accident the first time. But it is quite pretty.
Well, it has got a trick up its sleeve as well, because it's known as the Mexican jumping bean cluster. Because if you look at it through the eyepiece, and then you tap the side of your eyepiece as you're doing it, it makes it look like the star Tor wobbles independently to the rest of the cluster stars. And this is an optical effect which occurs when you have a brighter star and dimmer stars nearby. It just it takes a little bit longer for the dimmer stars to register in your optical system. So it looks like Tor is wobbling relative to the other stars, which is why it's got that name, the Mexican jumping bean cluster. Have you ever seen that?
I have not, no. But I will try to do it when we get a clear sky and that cluster's visible.
Okay.
Above Canis Major, well, we've got an indistinct constellation of Monoceros the unicorn. So it's very, very vague in terms of constellation.
Yes,
Unlike Orion or Taurus, there's no bright stars marking it. But there are some interesting things in here. In particular, the Milky Way passes right through it. And the Milky Way in winter is quite different to the summertime one, but it has a similar feature in that there will be rich in deep sky objects, mostly open clusters. But here you'll find the Rosette Nebula in Monoceros, which I found very difficult visually in the past, but I know it's a fairly good, easy target for astrophotographers.
Yes, it is. It's a very large object. It's got an apparent diameter of 1.3 degrees, which is nearly 3 full moons across. But visually, it is tricky. When you look at the region, I remember the first time I looked at it, I thought, it's just not here. They've made a mistake. And it's because what you see is the open cluster NGC 2244, which looks to me like the number 6 on a dice. That's the sort of general arrangement you've got there. But I have seen the Rosette with a relatively small refracting telescope with the use of an ultra high contrast filter.
Oh, okay.
And it's quite an eerie thing to look at when you do that, and it's quite amazing to see. So it's worth having a go for. Monoceros is an interesting constellation because it does, as you say, contain all of these bits and pieces. We've also got M50, which is the heart-shaped cluster. And we've also got the Christmas tree cluster and the Cone Nebula. And that region is full of nebulosity. It's got the Foxfur Nebula in there as well. And that's a popular thing to look at with a camera because you get some beautiful results. The cone is a dark bit of nebulosity which looks like a triangular, a pointed isosceles triangle cutting into this bright nebula. But the Christmas tree is quite interesting because it is a little asterism which looks like a Christmas tree, so it's a good time of year to look that one up. But I think that my favourite in Monoceros has to be Beta Monocerotis, which is a triple system. Have you ever seen that?
No, I haven't. But
well worth looking at.
I've overlooked it so many times. It is probably about time I had a look at it. So we have 3 stars of roughly similar brightness, separated at a similar distance of around 8 arc seconds, discovered by Sir William Herschel in 1782, and I believe described by him as one of the most beautiful sights in the heavens.
Yes, so you've got to go out and see it because it is quite striking, actually. I have seen it and I've imaged it as well, and it's a beautiful arrangement of stars. But just above the back of the unicorn, we have the constellation of Canis Minor, the little dog, which is an odd constellation in that Canis Major, the great dog, the one which contains Sirius, does look like a dog. The shape is the outline of a dog running up the sky towards its master Orion. But with Canis Minor, you've got Procyon, which is the brightest star, and then what's the other one called? Scormisa, which is Beta Canis Minoris, and it's just a line.
Yeah,
can you make a little dog out of that?
You can't really. It's a real stretch of the imagination to see this. Procyon is a nice star. It's quite bright, and as you say, it means before the dog. Reference to the fact that in the northern hemisphere, it always appears to rise before Sirius.
Yes.
Now, if you draw a line between Betelgeuse, Sirius, and Procyon, we have the winter triangle, which perhaps is nowhere near as impressive as the summer triangle. Nowhere near as long-lived either, because you can actually see the summer triangle low in the winter sky. But I think we've got plenty to see in the January night sky, and I hope all our viewers get some clear skies and able to enjoy them. Thanks, Pete.
Thank you very much, Paul.